We always had the mindset that, water flows into the Great Lakes and it flows out. So that means it's like a toilet. Every year it just sort of replenishes itself. Well, actually, that's not true. 98% of it doesn't go anywhere. It stays right there. It's only 2% that actually shifts at any time. So if you keep pumping pollution in there and 98% isn't going anywhere, what's going to happen? Well, it's staying right there. See, it isn't infinite at all. And this kind of an image gave us a new perspective. See, the young people here who have grown up with these images have a very different understanding of the universe than people like me. For me, this was a radical departure from what I had known. For you, this is just the way it's always been. You have a much better sense of this ecological relationship than people like myself. For me, it was something we had to develop, an understanding we had to develop. For you, it's more natural. But anyways, this changed our understanding of where we were in the universe. This is the Milky Way. Seldom do we ever get to see this, at least where I grew up. Maybe here you get to see it. Probably you do here. Where I grew up in Toronto, the only time I've ever seen it in Toronto is when we had a big blackout about 4 years ago, which was a great time because, first of all, you could see the sky, and second, and it was a good time. Everyone had a really good time because all the ice cream stores were just almost giving it away because with the power outage, it was just going to melt. So lots of good ice cream. And the restaurants, too, were doing special deals because, they had this food they had to sell because they couldn't refrigerate it. But this is the first time we got to see the Milky Way. It was really quite stunning. And this reminds us that we are in a universe, that we are not separate from this universe. See, when we were growing up, we still had this sort of pre-Copernican notion of the universe, that we were the center of the universe. Even though we'd say, oh, yeah, we know that that's not true, we still acted as if we were the center of the universe. But now we have this new universe story that says the universe began 13.7 billion years ago. Actually, that's a number that we say now. When I was starting my doctoral studies, the universe was considered to be 20 billion years old. And then after I finished my coursework, by that time it was down to 15 billion years. And then I was writing my thesis proposal, and by then it was down to 12.5 billion years. And then once I got my thesis proposal finished and I started writing my thesis, the Hubble Space Telescope gave us some new information that suggested, well, maybe it's only 8.5 billion years old. And I thought, boy, if I don't hurry up and finish, I'm going to run out of time. But we've been using 13.7 billion years for quite some time now. And so 13.7 billion years ago, we had this primal singularity, this little birthing point that was smaller than the smallest proton, but it was infinitely heavy. Hugely heavy and very, very small. And from that explosion, everything that is here today came. And so at the beginning, it was just pure energy, and eventually we get the formation of hydrogen, and then hydrogen bonding together to create helium, and eventually we get the first-generation stars. And after about 1 billion years, those first-generation stars start to explode, and in the heat of that explosion, we're able to get things like carbon and nitrogen and oxygen, which was really important for what reason? Why did we need carbon, nitrogen, and oxygen? Yeah, for life, for us. And if those first-generation stars hadn't all blown up, there'd be none of us here. And then eventually we get more stars forming and galaxies forming and galaxies upon galaxies. And then eventually you get the Milky Way galaxy and the formation of Earth. And then you get different kinds of life form, very primitive to begin with, and gradually they increase in complexity. And eventually you get to humans. So there you go, 13.7 billion years in about 2 minutes. So I've left out a couple of details. But anyways, that's us. That's us in the Milky Way galaxy. I always get a kick out of this slide because they say a photograph at the bottom. And it's not a photograph of the Milky Way galaxy. It's a photograph of a picture or a graphic of the Milky Way galaxy because we haven't been out that far. So let me try and tell the story a little bit differently so that you get a sense of the perspective on this. So if we were to think of this story as 15 billion years, and we'll use 15 billion years because it's an easier number to work with, and you're going to write, your teacher, Father John, has given you an assignment, and he says, I want you to write the history of the universe, and it's got to be a 30-volume set. 30-volume set, okay. And each volume is going to have 500 pages, and that means that each page is about 1 million years. Okay, so you're with me? So, and you can do the math. This actually works. I've checked it out, but if you don't believe me, go ahead, do the math. So a 30-volume set, 500 pages in each volume, and so that means every page is roughly 1 million years. Now, the most primitive form of cellular life on Earth would show up in volume 25. Volume 25. And the most primitive human civilization, the humans in their most primitive form, not even civilization, would be page 499 in volume 30. But human civilization would be the last 2 words on page 500. Right? See, we like to think it's all about us, but there were 29 other volumes where we weren't even in the volumes at all. And those are really good stories with really good character development and storylines and themes, et cetera, that were absolutely necessary for us to get to volume 30. In fact, what this tells us isn't so much that it's not about us, because it does tell us that, but it also says we're dependent on everything else that went before us. Let me give you a way of thinking about this. Carl Sagan used to ask a question, and he'd say, how long does it take to make an apple pie? Okay, so this is not a rhetorical question. I'm actually asking you this. How long does it take to make an apple pie? Yeah, an hour or 2, right? And he'd say, no. It takes 13.7 billion years to make an apple pie. And his point is it took that long for an apple to come into existence. And it took that long for a human with the ingenuity and the desire to make an apple pie to come into existence. See, you couldn't have an apple pie 10 billion years into the story. Well, there were no humans. There was no Earth. There was Earth, but there was no real life on Earth at that point. You might have had some prokaryotes, but that's about it. And prokaryotes have no interest in apple pies. So it took 13.7 billion years to make you, because it took 13.7 billion years for the universe to get to a level of complexity advanced enough to have a creature that could make an apple pie. See, you couldn't have been made in 10 billion years. You're so complex, it took 13.7 billion years to make you. So on the one hand, yes, we are the last 2 words on the last page. And so it isn't all about us. The other parts of the story are really, really important in and of themselves. But on the other hand, it took 13.7 billion years to get to us. So it's sort of a balance between the two. It also reminds us, though, that we're derivative from this story, that we are dependent on this story, that we were formed by this story, that we are not independent of this story. If you understand this new cosmology, this new epic of evolution, it reminds us that we're not separate from creation. In fact, we're completely dependent on it. When we go up into space, what do? We have to take oxygen with us. We have to take water with us. We suffer from the lack of gravity. So we have to do physical exercises up there so that we don't lose all the calcium from our bones. We're earthlings. We are formed by Earth. We are dependent on Earth. A nice way to think about this, Thomas Berry has this wonderful little statement. He says, you can't have healthy people on a sick planet. See, you get sick, well, the planet doesn't really do much to the planet. But if the planet's sick, you get sick. Tell the 20% of kids in Toronto who have asthma because of air pollution that. They understand you can't have healthy people on a sick planet. See, we are dependent on planetary health. We are directly connected to the health of the planet. So any notion that we are separate from it is just not real. But it's an attitude that we've had. And we see that attitude even in our language. So for instance, we say things like, I live on the earth. You'd never say to a fish, you live on the sea, right? A fish lives in the sea. The word in suggests intimacy. It suggests dependency. Well, we don't like that. We don't like this. We're self-autonomous. We're not dependent on anything. So we live on the earth. Because if I live on it, I can step off it. I'm not really part of it. Well, in fact, the earth, the planet Earth, continues well above us. In fact, that's a good thing it did. Otherwise, we'd have no atmosphere. So we live in the earth. Our language even betrays this notion that we're separate from it. And it was the idea that if I'm separate from it, it doesn't matter if I harm it, because it's over there. If I pollute and it's over there, it doesn't really matter. So let me ship my old computers to a third world country where the toxins in the computers can now pollute their environment and not mine. When I was in grade 9, Brother